Hi guys, this is Asif from Hezico, and today we're going to be creating an AI search engine using chromadb and Python. In the last video, we discussed vector databases and how they work, and today we're going to apply them and create our own search engine. So let's get started. Firstly, we'll use Python. So let's initialize a project. Okay, so now we're going to initialize the project. We are going to use UV. It's pretty straightforward to use it. So UV init, and then we're going to add chromadb, and we're going to add streamlit. Okay, now that we have initialized our packages, chromadb and streamlit, which are the main packages that we are going to be using here. Streamlit is basically a Python library that allows us to create web apps. Generally, when working with softwares, we tend to keep everything in a single framework. We could have used Python and a JavaScript framework to make the front end, but for the case of simplicity and the case of good practices, we're going to stick to Python and we're going to use Streamlit. So now let's start the project. Let's clean this up and let's import our files. Okay, these are the imports that we will use. We will import Streamlit, chromadb, a sentence transformer. This is basically using our own text embedding algorithm for our vector database. We can use the built-in OpenAI one for chromadb, but in this case, we are going to be using a custom one. We are going to import OS so that we can access the files on the system, import UUID to generate UIDs for the files that we save, and then we will add lists, dictionary, and the type of any, and then pandas to basically do some calculations. Okay, now we're going to define our class called AI search engine, initialize it, in which we will give it the model and client. So our client is going to be the chromadb client, and the model is going to be a mini LLM. This is a text embedding model, which is free to use. So this basically keeps everything local to our system. Then we're going to start a collection, basically naming our database, and then we are going to get that collection when we want to do that. If it exists, then we will just get it instead of initializing it each time we run. Okay, now we will do the next function called add document, where we will take the string. So whenever we're going to add a document, we're going to generate a UID for it. A UID is basically a string of unique numbers that we can assign to our entries inside our database. Then we're going to encode it using our embedding model. We will give it metadata, calling the source an uploaded document. We can also give more metadata, allowing the user to add a custom metadata as per their requirements. But in this case, we'll just label it an uploaded document. Once that's done, we'll just add it to our database. That is our add function. This was for files. And this is basically if you want to just add a simple text, right? So if it's multiple text that we want to add at the same time, we can just use this function. Pretty much the same thing, using a UID, encoding it, then assigning it metadata, and then just adding it to our collection. Okay, so this is our core function, which will search our vector database. So this will take a query, the number of results that we want to show. We will default it to 5. Then we'll assign the query to a variable, then take the results while querying our database using the collection.query method. Once we get that, we will then format the results into something visible. Also, in the case of chromadb, we will get like positive, negative values, because in the last video I discussed it uses L2 distance to calculate the distance between those points in the n-dimensional plane. So for that case, we will have to normalize the value so that it doesn't give us minuses. That way it won't break our visualization. Once that's done, we will just format those results and append them into the formatted results array, and then give us the results as a JSON. So it will have query, the results itself, and the total number of results. This is basically our search algorithm that we'll be using. Okay, so these are more helper functions to get the collection statistics and to clear our collection. So if we have some documents and if we want to clear everything, we can just call this function. This is to see how many documents we have and if they are prepped or not. Now these are some sample documents that we will add in our case. So if we want, we can keep it specific to the user and just have them add their own documents. But in this case, we will have some set documents so that we can just test it out rather than just adding new documents each time we want to test how this program works. So a few documents where we give it text, title, and its category, and then we return those sample documents. Okay, so once we have loaded our sample documents, we're going to use the load file content. This will allow us to upload text documents or PDF documents and just convert them into text string that we can just feed into our embedding model. Now we're going to create our main function. It is going to use some methods inside of ST to set up the page config, set up the markdown, set up the title, and basically give us the visuals of the page. Now, like I said, we are using ST, which is a new framework that you have to learn while building this out. I would recommend we can use the TypeScript version of chromadb as well. That way we can embed it into a JavaScript framework, and web apps on JavaScript are pretty straightforward to set. But the reason we're using Python is because we're using a custom embedding model. These are pretty simple to set up on Python as compared to JavaScript or TypeScript. Now let's initialize our search engine. And we're going to initialize the search engine. We're going to give it a loader, and then we're going to say this is the AI search engine. So this is the class that we assign it over here. Then we're going to create a sidebar. In that sidebar, we'll call it a document management, in which we'll create 2 columns. In both of these columns, we'll add documents and the status colors. This is pretty much visual stuff, and ST does a good job in handling these visual components, so we don't have to create them from scratch. Now this is the sidebar of the app. The column 1 and column 2, we initialize 2 columns in ST columns, where with we will define the first column in which we have load samples. On clicking this button, we will call the load sample documents. This will load all of those documents into our main database. And then in the second button, we use that to clear the document store that we have. So it will basically just call that clear connection. Now that's done, we're going to create another header to upload our documents. It will basically call the file uploader in ST. It will create a model, show us which files that we can upload. We have defined the type over here, so if it's something out of these types, it will not upload. Once we do call the upload function, it will call the upload function that we created in our main class, and then basically just process through that. Now we want to create a button for our custom document. So what this do is basically create a section, same thing as we've done before, create a form to allow us to add a document, then create 2 separate columns in which we will give it a title, a category, and then we will submit it by calling this function. Now the main page, where we have header called semantic search, pretty much the same structure that we followed before. So you can clearly just see that we're just creating the front end and just calling those functions and just visualizing how the page will look by using the ST columns, the size of the columns, what those columns do, where they get the data from, what the buttons do. This is pretty much what we are doing in these parts of the program. Now this is for the example query. If we want to run an example query, we will use this, where we take in the example query, set a boolean to true, and then move forward. Then this will basically call the search function. Once it searches on success, it will display the results from those functions, and we'll loop through those results to basically create those tabs in which we will see how the data looks, how far it is, how similar it is to our query. And then we wrap it up with this function where we finalize the footer of the website, and then we call the main function to just run this. Now we will run this program. To run this, we will do uv run streamlit run main.py. So you will notice that we're not using Python directly, we're using streamlit to run this program. Just make sure we use this rather than calling it directly from Python. If we do that, it will just break it. So streamlit will initialize streamlit and then run our Python program. Okay, sorry, I forgot. Now this will start running. Okay, so now once we run, it's going to take some time to initialize, and this is the final product. So we can see the columns that we created, we can see the visuals that we created using ST, and we can also see a search bar to call our search function, a load samples button that we created. Once we click this, it will take all of the documents that we set up in the sample and then have them in our vector store. Now let's see if we say data protection and search. We can see the security is the closest match to data protection, and then it gives us based on how close they are to that search query, it gives us the results, the percentage match, and we can also increase or decrease them. So let's say if we want 2 results and we search again, and then we get these documents. Now, this is pretty much how we can create our own search engine. We can also upload files. Over here, we can also create new text document like Hezico or nothing, and we can say Hezico is the best dev ever. And then we can add the document. Now we have 11 documents. Okay, so once the document is added, we can now just search, let's say Hezico, and search. It will come up as the document that we made. So it will give us the query, it will give us the source like we mentioned in our program. If it's a manual entry, it will specify it. Then it will give us the title and the contents of the file. So this is pretty much how we can make our own search engine using vector databases, Python, and using custom embedding models and keeping everything local. We can set this up end to end. Now we can make this more complex. Like once we have the files, we can use these files to basically create a chatbot that is context specific, or we can just create a chatbot that does a vector query. Using that vector query, takes the documents, loads them into the context of the app, and then basically gives you chat responses that are specific to that context. So the possibilities with this are endless. And if you want me to make this or make something more complex, or using TypeScript and JavaScript make a proper web app, just let me know in the comments, and I will see you guys next time.